Hello my dear students, good morning to you all. So in my last class, I was explaining about the reactions and reactivity of phenols. So there, exactly in the previous session, we studied what is Gattermann synthesis and how the mechanism is elucidated based on the different steps or the intermediates which are going to be formed, thereby producing the final product, so that is para-hydroxy benzaldehyde. And next, so what is meant by managed reaction, what is a managed base, so that is so dimethyl aminomethyl xylenol, so how it is produced or synthesized, and what are the two steps involved in understanding the mechanism of managed reaction. And in the last few minutes, so we understood what are aryl oxyacetic acids and the method of synthesis of aryl oxyacetic acids. Okay, so in this session we are supposed to start with a new chapter, that is chapter 4.2 in unit 4, which is called as ethers and epoxides. So in this chapter we are going to study the introduction to ethers, nomenclature, chemical reactions of ethers, cleavage by acids and auto-oxidation, Ziesel's method of estimation of methoxy bar ethoxy group in ethers, synthesis of epoxides, air oxidation, chlorohydrin formation and epoxidation of alkenes, acid and base catalyzed ring opening of epoxides, and at last explanation for orientation and reactivity of ring opening. So this is all about the blow up of the syllabus. So before going to the chemical reactions of ethers, let us have a brief introduction on ethers. So ethers, they are the organic compounds which have the general formula ROR dash. Okay, so those organic compounds which have ROR dash type of formula, they are called as ethers. So in this, so R or R dash are alkyl or aryl groups. Okay, so this R and R dash might be a alkyl group or a aryl group. So how this ethers are formed? When two alcohol molecules react under the proper conditions, they produce compounds with the general formula ROR dash. So the ethers are named by naming the radical on either side of the oxygen atom and adding the word ether. Okay, so in this way we are going to name them. As I said, so in this ROR dash, so if R and R dash are same, so then they are called as simple ethers. Okay, so if R and R dash are same, then they are simple ethers. If they are different, they are called mixed ethers. So suppose if R and R dash are different, then they are known as mixed ethers. Ethers are commonly named by writing the names of the two alkyl groups bonded to oxygen as separate words in alphabetical order and adding the word ether. Okay, so how we are going to do the nomenclature of ethers? So we are going to write the names of the two alkyl groups first, which are bonded to the oxygen. Okay, so exactly the oxygen atom must and should be present in all ethers. So we'll write the name of the two alkyl groups which are bonded to oxygen as separate words in alphabetical order and adding the word ether. In the IUPAC system, ether is named as the alkoxy derivative of the parent hydrocarbon of the large alkyl chain. Okay, so in this way we are going to do the nomenclature of ethers. So there are some examples. So this is ethyl group. Okay, so this is an example of simple ether because here R and R dash both are same, both are ethyl groups. So that is why how I am going to do the nomenclature is so diethyl ether. So this is diethyl ether. Suppose if R is CH3, that is methyl group, and R dash is C2H5, so then it is ethyl methyl ether. Okay, suppose if I have both C6H5 O C6H5, then diphenyl ether. Okay, so in this way I am going to do the nomenclature of ethers. Okay, so commonly, so diethyl ether is called as ethoxyethane. Okay, suppose if a methyl group is present, then it is methoxyethane. Okay, and suppose if two phenyl groups are attached on both sides of the oxygen, then it is called as phenoxybenzene. Okay, so in this way I am going to do the nomenclature of ethers. So these ethers, they are relatively unreactives, and as a result they are useful as solvents for fats, oils, waxes, perfumes, resins, dyes, gums and hydrocarbons. Vapors of certain ethers are used as insecticides, miticides and fumigants for soil. So these are some of the uses of ethers. So next is what are the chemical reactions of ethers? So in that the first one is cleavage by acids. When an ether is heated with dilute sulfuric acid under pressure, corresponding alcohol is obtained. So as I said in the beginning of this class, when two alcohol molecules react under the proper conditions, they produce compounds with general formula ROR dash, that is ethers. Okay, so for a organic compound ether to be synthesized, so there should be a reaction between the two alcohol molecules. In the same way, when this ether is heated with dilute sulfuric acid under pressure, corresponding alcohol is obtained. How it is formed? Say for example with dilute H2SO4, ROR, okay, so in the presence of dilute H2SO4, so we are going to get 2ROH. Okay, so this is a alcohol. Another example, that is C2H5O C2H5. In the presence of dilute H2SO4, it gives 2C2H5OL. Okay, so or it is also called as ethyl alcohol or ethanol. When warmed with concentrated sulfuric acid, what happens? So ethers form alkyl hydrogen sulfates. Okay, so this is when concentrated sulfuric acid is used. When C2H5O C2H5 is treated with the concentrated sulfuric acid, okay, and warmed or heated up, we are going to get alkyl hydrogen sulfates, and this is what is called as alkyl. C2H5 is an alkyl. Since hydrogen is present, alkyl hydrogen sulfate is obtained along with the removal of water molecule. Ethers are readily attacked by concentrated hydroiodic acid and hydrobromic acid. The product obtained depends on the temperature of the reactions. Okay, so this is the chemical reactions of ethers, that is cleavage by acids. This is how the cleavage by acids is going to take place in case of ethers. That is, when an ether is heated with dilute sulfuric acid, it forms the corresponding alcohols. Whereas when it is treated with concentrated sulfuric acid in certain amount of heat, so it forms alkyl hydrogen sulfates. Okay. Next is what happens so when mixed ethers are used, okay, or in cold conditions, so what is the reaction with halides? In the cold condition, a mixture of alkyl halide and alcohol is obtained. Okay, so I have taken a simple ether, that is ROR. When it is heated with hydrogen iodide, so it gives Ri plus ROH. Okay, so ROH, Ri is the alkyl halide and ROH is the alcohol which is obtained. A similar example is a diethyl ether C2H5O C2H5 when it is treated with the hydrogen iodide. Okay, so when it is treated with hydrogen iodide, I am going to get ethyl iodide, along with that ethanol is obtained. Okay, when mixed ethers are used, the alkyl iodide produced depends on the nature of the alkyl groups. Okay, suppose if you are using a mixed ethers, then the alkyl iodide which is produced, it depends upon the nature of the alkyl groups. If one group is methyl and other is primary or secondary alkyl group, it is methyl iodide which is formed. Okay, see, so here one is ethyl and another is methyl which is attached to this oxygen. So this is an example of mixed ether. When this is treated with hydrogen iodide, I am going to get methyl iodide and ethanol. This can be explained on the assumption that the mechanism in SN2. Okay, so if you understand the mechanism of SN2, nucleophilic substitution 2 reaction, so we can justify this. That is because the methyl group is a smaller group, so that it is going to form methyl iodide. It can easily react with the halide to form alkyl halides, and thereby ethanol is formed. Because of the steric effect of the larger group, iodide attacks the smaller methyl group. Okay, so this is what about SN2 reaction. For example, so methyl, this is ethyl methyl ether. If ethyl methyl ether is used, so then I am going to get a methyl iodide. So okay, so this is the example, ethyl methyl ether. If ethyl methyl ether is used, so then methyl iodide plus ethanol is formed. Suppose if methyl propyl ether is used, and if methyl propyl ether is made to react with hydrogen bromide, then methyl bromide is the product obtained. Along with that, isopropyl alcohol is formed. Okay. When a methyl tertiary alkyl ester is treated with concentrated hydrogen iodide, so this is tertiary butyl methyl ether. So when methyl tertiary butyl ether is treated with concentrated hydrogen iodide, alkyl iodide and methanol are obtained. So this can be explained by SN1 mechanism, in which the tertiary alkyl carbocation is produced because of its greater stability compared to a primary or secondary carbocation. For example, if you see here, so this is, as I said, tertiary butyl methyl ether. So when this is treated with hydrogen iodide, so we are going to get tertiary butyl iodide. Along with that, methanol or methyl alcohol is obtained. Okay, so for this reaction, we can give the explanation based on SN1 mechanism, because according to the SN1 mechanism, the tertiary alkyl carbocation is produced. So this is because of its greater stability. So tertiary butyl carbocation is more stable than the secondary or primary alkyl carbocation. So due to this greater stability compared to the primary and secondary carbocation, so we can expect a tertiary butyl iodide as a major product. Along with that, methyl alcohol is obtained. Whereas when heated with the alkyl iodide, what happens is, so alkyl iodide is obtained when ether is treated with this hydrogen iodide. Okay, so under certain amount of heat, we are going to get the product as alkyl iodide, that is 2Ri plus water molecule is eliminated. Due to the low reactivity at the bond between oxygen and the aromatic ring, aryl alkyl ethers cleaves to form a phenol and an alkyl halide. Suppose if you take a ether which is having an aromatic ring, so that is phenyl methyl ether. Okay, so this is phenyl, since it has got a aromatic ring or benzene ring, phenyl methyl ether, and the general name of this is anisole. When this is treated with hydrogen bromide, and heated to a certain amount, so what happens is, so here the alkyl ether cleaves to form a phenol and methyl bromide. Okay, so due to the low reactivity at the bond between oxygen and the aromatic ring, so aryl alkyl ether cleaves to form a phenol and an alkyl halide. Next is about auto-oxidation. Ethers combine with atmospheric oxygen to form peroxides. So ethers are very reactive towards the atmospheric oxygen which is present. For example, so this is diethyl ether C2H5O C2H5, or this can be written as CH3CH2O CH2CH3. So both are same, diethyl ether. When it comes in contact with atmospheric oxygen, that is in long contact, peroxide of diethyl ether is obtained or formed. Ethers that are exposed to atmosphere for a long time contains peroxides. They are hazardous because peroxides decompose violently at higher temperature. So that is why we should be very careful while handling with the ethers. So ethers can easily react with the atmospheric oxygen. They can catch fire. So they are hazardous. This is because of the formation of the peroxides which decompose violently at higher temperatures. When a sample of ether containing peroxides is distilled, the peroxides concentrate in the residue. At the end of the distillation, the temperature increases and the residual peroxide may explode. Hence, ether should never be evaporated to dryness. Okay, so this is very important to understand while handling or dealing with ethers. And next is estimation of number of methoxy bar ethoxy groups in an ether by Ziesel's method. The reaction between an ether and hydroiodic acid is used to estimate the number of methoxy or ethoxy groups in a compound. A known mass, say Wg grams, of the compound of molecular weight m is treated with 57% of hydroiodic acid when methoxy or ethoxy groups change into the corresponding iodides. So this is the reaction. So here a methyl iodide or hydrogen iodide, when it is treated with this ether, a methyl iodide is formed. The methyl iodide or ethyl iodide thus liberated is absorbed in a alcoholic silver nitrate solution. Okay, so what amount of methyl iodide or ethyl iodide is liberated during this reaction? Okay, so when ether is say for example W gram of ether compound of m molecular weight is treated with 57% of hydrogen iodide, then we are going to get alcohol. Along with that, methyl iodide is going to be eliminated or liberated. So this liberated methyl iodide is absorbed in alcoholic silver nitrate solution. So what happens then? So when this methyl iodide treats with silver nitrate, so we are going to get a silver iodide. So silver iodide is precipitated out. Okay. So this silver iodide which is precipitated, so that precipitate is filtered, washed, dried and weighed. And next let the mass of the silver iodide obtained be small w gram. Okay, so that is Wg. So let me call that the mass of silver iodide as a small w. 1 mole of silver iodide precipitate corresponds to the presence of 1 methoxy or 1 ethoxy group. Okay, so as the case may be, so when Wg of the compound containing methoxy group gives a small Wg of silver iodide, then therefore mass or m gram of the compound containing methoxy group gives how much grams of silver iodide. So this is cross multiplied small w divided by capital W into m grams of silver iodide. We know the molecular weight of silver iodide is 235. Okay, so because molecular weight of silver iodide is 235, let me substitute that value here. So W divided by capital W into M divided by 235. So if we calculate this by knowing the weight of the molecular compound or the known mass of ether, okay, so by knowing the known mass of ether which we have taken, and by knowing the mass of silver iodide which is obtained, that is small w, okay, so here capital W represents or corresponds to the mass of the compound. Which compound? The first one, the ether which we have taken. So capital W is the mass of ether and small w is the mass of silver iodide, and here capital M is molecular weight. Okay, so molecular weight of the ether compound which we have taken divided by m grams of silver iodide, that is molecular weight of silver iodide, that is 235. By knowing all these parameters, if we substitute here and if we calculate, so hence the number of methoxy groups present in the molecule is equals to X. So X is a certain number. So in this way we can determine or estimate the number of methoxy bar ethoxy groups in an ether by Ziesel's method. Okay, so I hope you understood this. So if you want, I will repeat it again in 2 minutes, so let it be very clear. So to do the estimation of number of methoxy or ethoxy groups in an ether by Ziesel's method, what we are going to do is so we are going to take a known mass of Wg compound. W is a known mass, say for example 1 gram. 1 gram of ether of m molecular weight, say for example 50 molecular weight, is taken and it is treated with 57% of hydrogen iodide. Okay, so what happens when this reaction is done? So we are going to get corresponding alcohols, along with that methyl iodide. According to this, so methyl iodide is liberated. So this methyl iodide which is liberated, so it is absorbed in an alcoholic silver nitrate. Okay, so this is silver nitrate. So methyl iodide is absorbed in an alcoholic silver nitrate. What happens? Silver iodide is precipitated out. So this precipitated silver iodide is used to calculate the number of methoxy or ethoxy groups. So here the mass of silver iodide which is precipitated, so that is called as small letter Wg. So that means so capital letter Wg, that is the mass of ether compound, gives a certain amount, that is small letter Wg amount of silver iodide. Okay, I hope it is understood. So now, therefore, m gram of the compound containing methoxy groups gives so much grams of silver iodide. So that is why we have to cross multiply it. So here small letter w corresponds to the mass of silver iodide. Capital letter W corresponds to the mass of the ether compound into so molecular weight or the grams of silver iodide. So the grams of silver iodide is written as m divided by the molecular weight of silver iodide. Okay, so this is simplified, and we know the molecular weight of silver iodide is equals to 235. Substitute all the values and calculate it. So we are going to get the number of methoxy groups present in the molecule. Okay, so in this way we are going to estimate the number of methoxy or ethoxy groups in an ether by Ziesel's method. So I am going to stop it here. In my next class we will understand about epoxides. Okay, so this is all about ethers, and in my next class we will discuss about epoxides and how we are going to do the nomenclature of epoxides, different epoxides, and how the synthesis of epoxides is done. Okay, so there we will see air oxidation, chlorohydrin formation method, epoxidation of alkenes, ring opening of epoxides, all these things. Okay, thank you dear students. We will meet in my next class.